Okay. Hello, this is Mohammed Furkan, and I will be presenting assignment 2 of CML 102. So, what we want to do is basically we want to solve and refine the crystal structures that were given to us uh, using the OLEX software. And for that, uh, what we do is we take the data that was given to us in the form of INS and HKL files. So, I opened the INS file using the OLEX software, and basically we want to refine the R factor so that the model that we propose is as close to the actual one as possible. So initially we open the INS file, then we only get these alpha, beta, gamma, and ABC parameters. There are no uh, there are no more things that are visible here. And then what we do is we solve this structure using the shellxs program, and from there we get some atoms here, and this gives some a rough idea of what it can be. So initially we might get like five atoms here, and then based on their intensities change we can get different kind of atoms. Okay, so first of all we can identify that there was a six a membered ring here, the phenyl ring, and then we label these things by the carbon atoms. So from here we do the labeling, we click on this atom and then we click on this carbon to get this gray thing, which is the notation for the uh, carbon atom. Okay, and then basically this gives me a rough formula, and I'm not sure what kind of structure is this, but I will try to propose some that this atom is this atom, and then we might get some better R factors, and based on that, we can say that the model is much better than the previous one. Okay, so we first identify this phenyl ring, and then we move on to the other ring. So we get another six-membered ring, which is a different ring, as we can see in the structure of hydrochlorothiazide. So I will just show that structure. So for the hydrochlorothiazide, the structure is something like this. So you get a phenyl ring, and then you get a five-membered ring with sulfur and two nitrogens, and then oxygens and all these things, chlorines and nitrogens. Okay, so for that, basically we first identified these sulfur atoms. Okay, and then based on the sulfur atoms, and then there was a nitrogen atom close to this, so we identified the nitrogen atoms, and these were my nitrogen atoms. I can, based on this structure, I can get my nitrogen atoms. I can guess that okay, there is a nitrogen atom close to the adjacent to the sulfur atom, and then there is another nitrogen atom, and then there are two oxygens that are joined to the sulfur atom. So this part is not problematic. This part, this phenyl ring is not problematic, and then this six membered ring is not problematic with sulfur, nitrogen, and both oxygens, because like the sulfur atomic number is I guess 16, and the nitrogen is uh, different. So like we will not get any problems here. Okay, this is fine, I guess. Okay, the problem is in this part, like the groups that are attached to the phenyl ring. So for this thing, we have a chlorine atom, and then there is sulfur and two oxygen atoms, then NH2. So this is slightly problematic. So for that, we first need to identify which one is the chlorine atom, right? So that we can do by just okay. So this thing, this green one, this thing is my chlorine atom. So I will identify that, and I will further refine the R factor, and I will get a better R factor. So which tells us that this thing is a chlorine atom, and then I will get my other sulfur atom. But then I don't know which one is oxygen and which one is nitrogen. So, but I know that the sulfur oxygen bond length is shorter than the sulfur nitrogen bond length, because like it's a double bond. So I will click on these bonds, and then I will get that some data for that, and based on that I will decide that okay, this one is oxygen, this one is oxygen, and then the other one, the odd one out, which will be around 1.4 angstrom, that will be nitrogen, and then I can further refine my structure to get a better R factor. So this is this like now we are done with all the heavy atoms, and we only need to analyze the hydrogen atoms. So for the hydrogen atoms, what I will do is, I know that they are these attached to these carbon, nitrogen, and all these things. And then these carbon atoms, they are in case of this phenyl ring, they are in sp2 hybridization. So the hydrogen atoms will be in a plane. So based on that, I can guess my hydrogen atoms. So this is what we do, or simply what we can do is we can directly add using the software these hydrogen atoms. So that will also be helpful. And then we can further refine my R factor. The R factor that we got was 3.76 for the first one, for the first data. And this is hydrochlorothiazide. Okay. Then I will move on to these things later. Then the molecular structure of data 2. Okay. So in data 2 also, we have a phenyl ring. So the structure is for the rulizole thing. Okay, that was given to us. Riluzole, sorry. So there is a phenyl ring here, as we can see. There is a phenyl ring. This we can easily identify simply. And then we have these heavy atoms. There is a five-membered ring, and then we need to identify the sulfur atoms, the nitrogen atom. The sulfur atom will be identified, and then you have nitrogen atom where these hydrogens are attached. So this ring and this ring is pretty much sorted. This group is slightly different. Okay, so this is oxygen, and then there are three fluorine atoms. So you can identify your oxygen atom. This will give me my oxygen atom, and then I can identify these fluorine atoms. Okay, so this part is, I don't think this is very problematic. This, the software does almost everything. And then this part, this is the thing coming from the malonic acid, right? So this part basically. So this, you can identify these carbon atoms, right? And then you have oxygen atoms attached to them. And then there is, I think this is, they are showing the, in case this hydrogen, there is some hydrogen bonding between these two. Possibly they are showing that thing. Okay, so you can identify your oxygen atoms from here. This is pretty much the same thing that we followed here. First we identify the benzene ring, first we identify all the rings in the atoms, and then there is some guess that is made by the software. So and after that we can, the only problem that arises is when the softwares have a similar uh, similar atomic number electron densities. The software basically works on these electron densities, right? This basically does a Fourier analysis. So I think this is fine. The R factor that we got for data 2 is 3.70, and then we did for data 3. So for data 3 we get something like this. We identify this phenyl ring, the five-membered ring, then there's sulfur, there is nitrogen, then there are groups attached to this. This orthophosphoric acid is attached to this thing, this riluzole. This is similar to what we got here. This thing is same, and this thing is same, and this is the orthophosphoric acid, the phosphorus with like these oxygens. Okay, this is, I think, fine. Then what we do is using uh, and the R factor that we got for the data 3 was 3.67, something like that. And then what we want to do is we want to find the crystal structure for this. So for the crystal structure, I will make a CIF file using the ACTA program, sorry, using the ACTA option in this software in OLEX. And then from that, I will get my CIF file, and I will open my CIF file from the Vesta software. That was the previous assignment, and it's much that we already did this in case of like crystal structures of different uh, lattices that were given in the last assignment. Okay, and based on that, we get the crystal structure for data 1, and then the powder diffraction pattern. The powder diffraction pattern, we know that this was something like I intensity versus 2 theta graph, and based on the positions of these things, these are the FHKL's values are stored within this lattice, within this lattice structure. So the all the software has to do is it has to just compute the sigma e to the power 2 pi I hx x thing and the summation of all those things. And this does by a single click. You can just use the utilities option in the Vesta software, and then you can directly get the intensity versus 2 theta graphs for data 1, for data 2, and for this is for data 2, and this is for data 3. I think this is enough for this thing. I have uh, wrote down the R factors. These were the molecules that were given to us. Thank you so much. I think this is enough.